Hi, I'm Z. Today, I'm going to talk with you about the wonders of AI agents and how you can run them with whatever model you want without breaking the bank. So let's start out by imagining something. Imagine that this is you. You wake up one day, you go to a meeting. Your boss is there, and he's insisting that your product needs to have AI, but there's one small problem. What does this mean? Well, let's assume it's something sensible. Like, maybe you're not a company that sells bottled water, but there is something sensible that you can do with AI. But the mandate has come in from heaven, and now you're the one that needs to go and implement it. You're probably asking yourself questions like this. Like, okay, so I have to make AI happen. What are the moving parts? What can I buy? What do I need to build? What are the pros and cons of different infrastructure setups? When your boss talks about things like AI agents, what does he actually mean? And most importantly, how can I avoid spending a lot of money on this? Thankfully, the AI agent question is easy to answer. An AI agent is just a model that has access to tools like escalate ticket or run SQL query, or maybe even something as banal as drawing an image. The rest of the hype comes in from square peg, round hole to existing things like ETL nonsense with MuleSoft or other boring things like that. But really, when people say AI agents, just think square peg, round hole. So if an agent is just a model with access to tools, how do you make that happen? Let's look over the moving parts of AI. To keep it simple, I'm going to break it into 4 parts. The first part is the model. A model is fundamentally a big ball of floating point numbers that just happen to be the results of a bunch unimaginable amounts of text going through them. These models take input, turn them into tokens, turn those tokens into embeddings, do whatever the hell CUDA does, and then get you new tokens out the other end. Those tokens usually happen to correlate to words. There's hundreds of models out there, but if you're in luck, you should try, but if you're in doubt or don't know where to start, you should try Facebook's Llama series of models, DeepSeek B3, or maybe even one of OpenAI's models. They're usually good enough to start out with. Next, you have the inference engine. This is the thing that actually runs the model. There's a few options on the market for inference engines, but usually you use something like Ollama, Llama CPP, or whatever the heck they do in Python. And you'll have an OpenAI API client that hooks into the inference engine, and you mostly treat it as a black box. But this is the part that needs the GPU to run and the expensive part. When you pay OpenAI or DeepSeek for access to a model, the part they host is the model and the inference engine. Now we get to your code. Your code is going to be the thing that sits in the middle, wrapping the front end around the AI model and doing whatever square peg, round hole you need from the input format of the AI stuff to the output format the AI returns and sending it off to the next layer. This is the part that's the most diverse and opinionated, so I'm going to cover it the least. And finally, there's the sparkle emoji button. This is the chat box that pops up when a user clicks on that sparkle emoji button, the tool that summarizes the meeting transcripts for action notes or whatever your CEO thinks he wants. And that's it. This is all the moving parts. The AI models get run by the inference engine, your code calls the inference engine, and then presents the results to the UI. It's basically the same thing as a database in the standard 3-tier web app architecture. When you get started, you'll see a setup like this. The example code that you're cloning from GitHub will almost certainly call OpenAI's API, pass the input and context there, maybe spin in a loop to handle tool calls depending on how it's set up. It'll have a UI that kind of looks like ChatGPT's UI because that's the hello world of AI stuff. You pay per million tokens. Like, let's be real for a second. This is probably good enough for most production workloads. Like, especially where confidentiality doesn't matter and you're not having to do excessive acronym compliance. OpenAI's SRE team is really on the ball, and it's super easy to set up. Like, all you need is a corp card and an API key. It works on any laptop or server with an internet connection, which in 99.9% of cases is all of them. It's easy to think about and easy to compartmentalize. You get access to some of the best models on the market, and it works out. Depending on how you use the model, what model you use, the phase of the moon, and other innumerable things, you probably will pay like $1,000 a month on the way far edge of the bell curve. You have to do some science, but That's what computers are for, right? Computer science. However, roses have thorns. And there's some pretty insidious ones that you may need to keep in mind that may make you think otherwise for this exact strategy. The biggest problem is one of the biggest advantages. You're relying on OpenAI or the other provider to keep the model up. This means you don't need to purchase GPUs or worry about uptime, but let's face it, one of the big providers being down, you're not the only one affected. But you're relying on them to keep the product functional. This is a huge position of power. They're selling almost all of the providers are selling their products at a loss to get adoption. Someday, the financial cows will come home along with massive price hikes. Like, OpenAI and other providers can and will deprecate that one model that all your production workloads hinge on. Like, this example is showing GPT-3, or certain snapshots of GPT 3.5 being replaced by other ones. And normally, this shouldn't be an effectful change, asterisk, but sometimes it can have massive consequences in subtle ways on your app. One time, I changed a model from one version of a model to another, and my chatbot went from, just happy and normal to a full-blown depressive episode. No, seriously. Imagine how much your app's behavior could change if, like, some key thing just goes weird. And then they send you deprecation warning emails. Raise your hand if you actually read deprecation warning emails. For the record, 3 people raised their hand. Yeah, see, nobody reads them. Suddenly, when things get actually turned off, it's your emergency, and you get to start learning about the joys of hyperparameters or having to have the dreaded conversation of, sorry, boss, sparkle emoji button's broken, it's out of our hands. Do you really want to hand over the keys to the kingdom to someone else? So, you're inevitably tempted to want to self-host all the things. After all, if the code is calling your server, deprecations are on your schedule, right? This is a nice idea. It sounds really good to the ear. Let's take a look at what the stack looks like compared to the other one. It looks basically the same, but it's a little bit different. Instead of asking OpenAI's API, you ask your own pool of GPU servers to run the model with the question and the context. The API endpoint transfer, it converts whatever you send into whatever the GPUs actually need, does whatever it does when mixing the pile of linear algebra around, and returns the results to get back to the user. The other main difference is that you're going to have to store the model somewhere because, like, a 70 billion parameter model at float 16 precision is at least 140 gigabytes of floating point numbers across n servers. That is big data. Like, officially, that is bigger data than most people's laptop RAM. That is the threshold for big data now. In practice, you'll probably end up storing your models in object storage like Tigris and then cache them to the inference server so they load fast. But otherwise, your app shouldn't really notice or care there's another model in the equation. You'll have some semantic differences, but really you can iron them out. It's just annoying when the semantic differences happen without warning. This is a bit more complicated than relying on a third party, but the strategy has significant upsides that can make up for it in some circumstances. Biggest one, most obvious one, it's your stack. When you're calling models on your servers, you own the stack. You get to choose what models are available. You get to choose the deprecation schedule. You get to mix and match models that will. Like, some of your app needs a model from 2 years ago. Great, you can do that. Something needs a model that was released yesterday. Assuming you have the hardware, what's stopping you? Yourself? No, what's stopping you is the amount of free time because you have to keep doing new features, eh? You also get to choose the models. You're not just limited to the ones that your provider has available. The ones that your providers provide are usually good enough, but what if you want to fine-tune a model for your exact use case or experiment with a new model like DeepSeek R1? What if you need to see the reasoning output in your flows? Many providers won't let you do that, but self-hosting, you can do whatever you want. Finally, the last big advantage of self-hosting is that nothing is sent to third parties. This can be very important in acronym compliance like HIPAA or GDPR. This can make self-hosting more than worth the costs in many cases, such as using AI models to analyze trends in medical records, which seems to be a pattern that people are doing for some reason. Nobody is going to even imagine allowing you to pipe all that data to OpenAI or DeepSeek, no matter what acronyms they're compliant with. Also, what if your app touches LGBTQ issues, menstruation schedules, or something that the current political zeitgeist might label wrongthink? OpenAI or the other providers could just turn off answering questions like, I don't feel like my body is right. Is there something I can do to find out why or fix this? You'd just be out of luck. Your self-hosted models, though, would be totally unaffected. Of course, this isn't free puppies and rainbows. There's some significant downsides in self-hosting your AI workloads, and they can be subtle and kind of insidious. The big one is that the NVIDIA drivers are stable, asterisk. The NVIDIA drivers will become the bane of your existence. They're normally stable, but they can and will fall over at notice at 3 a.m. That is the SRE witching hour. It'll never fall over during work hours, because why would it? It's always during the witching hour. You'll have to deal with the NVIDIA drivers that have no introspection into what's going on, suddenly deciding that, you know what, uptime, that's for cowards. You can work around this with worker pools and redundancy. That can change the price, considerations, everything's a trade-off. Another downside is that you have to choose what models you're using. There's so many options out there, it can be paralyzing. Like on Hugging Face, there's probably over 1,000 different variants of Llama 2, and God knows how many models total. But like I said earlier, the Facebook Llama models are a good place to start. They're generalists, they're good at a lot of things, not really good at anything in particular. It'll get you a feel for what's possible. Eventually, you end up learning how to pick models for individual things. This is a skill you have to learn. It is learnable, but you have to learn it. Again, everything is a trade-off. Also, when you're self-hosting, you have to have opinions about how things are done. You have to choose between OLlama or Llama CPP or VLLM, or know how to use the Python stack to do whatever you want. This is fine. Like, I use OLlama for a lot of my stuff because it works well enough that I don't have to think about it, but you have to have the opinions. I had to spend the time developing the opinions. It'll work out. It's just, you have to have the opinions. But the time to have opinions doesn't really exist when the boss is breathing down your neck, wanting to show investors the sparkle emoji button. There's only one problem with self-hosting that's not as easy to work around as just having the time to have opinions. When you do this, you're going to need GPUs by NVIDIA. Like, sure, you can try other things like AMD GPUs or try running it on Apple Silicon. I can't stop you from hurting yourself. Realistically, NVIDIA cards are the path to least resistance in production. The lead time for NVIDIA GPUs is measured in months. And you can only get like single-digit numbers of them. When you do get them, they're really expensive. We're talking on the order of $40,000 per card. And you can only buy them in packs of 8 with like high-end all-yes config servers. Like, one of those servers costs like $200,000. Not to mention the fact that they need like 5 kilowatts of power at full bore. And not to mention the data center technician time to handle the hardware failure. Like, sure, you can get the cards you need off of eBay, Taobao, Alibaba, or GPU Craig on Craigslist. But sooner or later, your employees are going to run out of spare kidneys. You'll run out of budget party for all the pizza parties to make up for the kidney donations. And venture capitals want a return on investment. Even more fun, when you do get those GPUs and you have them full bore, service life of 1 to 3 years. Then you get to start it all over again. I'm kind of amazed that anyone's able to really put up with this, but this is the kind of hidden cost of AI that they don't tell you about in the sticker price. I don't know if it's really worth it to self-host everything. I did the self-hosting flow for my chatbot, for my home lab, and it did work, but there's just one problem. NVIDIA seems dead set on making sure that consumers have like the bare minimum amount of VRAM they need to render polygons and nothing else. I wanted to experiment with bigger and bigger models, but I didn't have enough dedicated VRAM. I had to branch out into the cloud. So there's got to be some middle path between these two extremes, right? Both of these just seem like they're different types of suckitude. There is a middle path. It's called nomadic compute. This is a buzzword that I'm trying to introduce into the collective unconscious of the technology industry. Nomadic compute is cheating, but strategically cheating, and knowing exactly how and when you should cheat. It all revolves around taking advantage of user patterns and the fundamental constants of the infrastructure we're all working on top of. In a nomadic compute setup, imagine your workload hunting down the best deal between providers based on the exact requirements of that workload. You spin up more when you need them, you slay the excess off when you don't. It's a pretty good thing in practice, I've found. The biggest key to how this works is by taking advantage of one fundamental constant between every provider. GPUs are fungible. There's nothing really special about any one A100 compared to any other A100. The main difference is the price and the amount of video memory. Also, every cloud provider and their mom has GPUs these days. I've seen single-person VPS companies on lowendbox.com advertise NVIDIA GPUs. They're everywhere, and because there's so much competition, you can get a good deal from basically anyone. And also, from an AI standpoint, there's only 3 specifications on a GPU that actually matter: the model year, the amount of video memory, and the memory bandwidth. Every other spec on the GPU doesn't matter, because fundamentally, language models are constrained by the amount of VRAM and memory bandwidth. And the model year is a proxy for how fast the individual processors are, but that doesn't matter as much as memory bandwidth. More model year number, more faster. More VRAM amount, more bigger. More memory bandwidth, more throughput. Like, that's it. And also, you don't need the newest possible cards. My AI workflows actually use older cards that are now 3 generations old, like the NVIDIA A100. It is way more than sufficient for my needs, but because it keeps getting 1 generation older and older, the price per hour goes down. I pay less for the same experience. But if you try to make something yourself to switch between providers, you're going to look like this. All of the APIs have different corner cases. There's lots of undocumented fundamentals about every cloud provider, because why would they document how the entry point in your Docker image starts? Like, why would you need that documented? You can just figure it out, right? Luckily, though, it's the future. And there's this tool, SkyPilot. The TLDR of SkyPilot is you describe what you want, and then SkyPilot, load it up with API keys for a bunch of different platforms. SkyPilot will figure out the best deal for you and just start it up there. You can even have it auto-scale workloads based on HTTP request pressure. So you can just sit back and let your app go viral because the infrastructure layer will just figure it out for you. So when you're trying to implement a nomadic compute setup, I wish that I could give you like a push-button receive bacon example, but this is diverse enough because as much as I'd love to say that it isn't, AI stuff is all really specific to the exact use case. Like, you know, like generate text, or given this image, is it a picture of a horse? If you're trying to do this for yourself, keep these ideas in mind. Make everything as boring as you possibly can. Sure, you may want to use DynamoDB or something else that only one provider provides. No, do not do that. You have already spent all of your innovation budget on the AI. Pick super boring and battle-tested tools. Use Postgres. Use object storage. Don't use anything local, and make sure that whatever you do, you can run it anywhere with an internet connection and an NVIDIA GPU. By the way, fun fact, WireGuard lets you run it in user space. Take advantage of this. In your 3-tier web app diagrams, like I said, put your AI infrastructure in the same tier as databases. Like, really, in the 3-tier architecture, you have the front end, the back end, and the weird ancillary support surfaces. These just so happen to usually include databases or whatever microservices you have in your cluster of fun, right? And what is a database server but just an internal service with a weird API? Your AI services are the same. Finally, scale things down when they're not in use. Why should you have to pay for compute time that's sitting there doing nothing? Cold starts can suck, but nomadic compute is cheating. One of the big ways you can cheat is by putting your model weights directly into the Docker image. This does have scaling limits, like Docker will not be happy with a 140 gigabyte floating point weight file, but there are ways that you can work around and mitigate a lot of the suckitude. Also, with many platforms, while the image is being pulled, and if the image contains the weights, you don't pay for the pull time. Think about that. Auto-scaling is love. Auto-scaling is life. So an example of nomadic compute is one of the chatbots that I've made over the years called Mimi. Mimi is one of the characters in the iaso.net cinematic universe, and when I made her into a chatbot, I wanted to make something to amuse people and make them laugh. But like any good project, Mimi is actually kind of complicated and has a few microservices, because why not? Mimi gets chat messages from Discord. If she's interested in them, I have like this complicated, do I need to pay attention logic. It passes them to the GPU over a service a friend made called Glaceon. Glaceon connects over to the cloud using user space WireGuard to get to the copy of Olama, spin it up when it needs to, spin it down when it doesn't need it, and then the Go code decides what to do next. If it decides that it wants to draw an image, it sends a request to this ancillary support service called Faline, which sends it to fal.ai, and then Faline gets the image back, it puts a copy in Tigris, sends the URL back to the bot, which uploads it to Discord, and people see a picture of a cat dancing tango. I don't know why they'd want to, but that's the power of AI. Mimi remembers things long-term with PG vector. Okay, Mimi should remember things long-term with PG vector. She's just very bad at it. I need to fix it. This is my second conference talk this week. Maybe I'll fix it. Maybe I'll have time. Who knows? But like I said, when I started out, I wanted to self-host all the things so I could have Mimi be one of the only AI chatbots within my group of friends that actually did that. I wanted to run everything on computers that I could look at, which, by the way, it's a very great way to describe self-hosting in like computers that you can look at. Reality got in the way. Mimi used to run across 3 nodes in my home lab. One of them ran Olama, and that's what generated Mimi's responses. Sometimes it sent a tool call request, and then it would send the request to Comfy UI, and that would upload the image to the cloud, spit back the URL, and then Mimi would use that to post it to Discord. This worked really well, but then a shiny new toy came out. Facebook released Llama 3. It had 70 billion parameters. The benchmark said it was good. My MacBook had enough RAM to run it, and I did some testing with a version of Mimi, and it worked really well. But there was a small problem. It needed 48 gigabytes of VRAM to run. My home lab server has a GPU with 12 gigabytes of VRAM. As we all know, 48 is like 4 times bigger than 12, so that won't fit. This is when I had to compromise, and this compromise led to me envisioning the idea of nomadic compute. It's okay to use the cloud. Just make sure you have an exit strategy. So when I've been using the models, I've been making sure to use open weights models so that I can put them somewhere else if I need to. I reach out to the open weights models over a private network. I have like dynamic auto-scaling logic and all that. And this allows me to move it around should I need to. Like, sure, it would be inconvenient, but it would be a mild annoyance, not a showstopper. I use the same API, I just hit a different endpoint. Remember, GPUs are fungible. If you can get the thing to do the same thing somewhere else, and it's cheaper, why not? It's okay to ship parts of your AI apps out to the cloud. You just have to make sure there's an exit strategy. Like, here's a great example of how you can make those sets of compromises. When I have that image drawing tool for my AI bot, originally I was using Stable Diffusion 1.5. That model is one of the older ones. I find it can make some really good aesthetically pleasing results, but I have a lot of experience with it. It runs on basically no VRAM, But there was one big problem that I came into. Mimi's model did not generate things that were optimized for Stable Diffusion 1.5. The results could get biblically accurate. To save your sanity, I'm not going to expose you to how bad it could have gotten, but trust me, when you're trying to get a picture of a cat doing tango, you don't want that cat to have 5 heads. Flux came out, and in my testing, the prompts that Mimi generated actually resulted in reasonable things with Flux. Flux was too big for my home lab again. 12 billion parameters, but in practice, it needed like 20 gigabytes of VRAM. I would have to get an RTX 4090, and in Maple dollars, that's like many dollars. I didn't have the power budget for that. I could fit it onto my gaming GPU if I squished things in, but then I couldn't use it for gaming. And then I found out about FAL. FAL could just run Flux for me, and I pay for the output per image. With the exact model that Mimi uses, I pay 3/10 of a penny per image. That is literally less than the power I'd pay to run the power cost for running the model locally on a 4090. It just made sense. But remember, worst case, it's using Flux Schnell. So I can just take Flux Schnell and put it somewhere else if I need to. All with the power of nomadic compute. And as a result, this is what Mimi's infrastructure looks like. Everything that can turn off when it's idle does. I get Mimi to scale down when she's not in use, but Mimi has to stay connected to Discord. It's pretty nice in practice. I've done the math, and I pay about $5 per month for the cloud stuff that Mimi does, and most of it is inference time for the GPU. For what's going on under the hood, I think that's really cool. Before we finish this up, I'm going to cover some of the biggest lessons I've learned running AI workloads that'll save you time and money as you implement the sparkle emoji for your boss. Every input to the AI model matters, and like even small changes to things can drastically alter the outputs and behavior of your product. Like there was this paper that Apple wrote where they had they were trying to get the model to see if models had an internal worldview. So they asked the question, what weighs more? 2 pounds of bricks, 1 pound of feathers, or 3 pounds of air? AI models almost always said the bricks were heavier. Generally, when you think about AI systems, you kind of want to think about it like this. You take the prompt, you pass it through the XKCD comic of linear algebra, and you get the result. And you just mangle the langle the right way, and you get an output. And usually this is the case, and usually it works out. Asterisk. Sometimes there's hidden inputs in the mix that can seem pretty banal, such as the date and time of the user making the requests. This can have hilarious results. Like Claude gets lazy around August. August is stereotypically when Europe goes on vacation. ChatGPT gets really bad output in December, around the time when Americans ritualistically give up for the year. If your app doesn't need a bit of input, don't give it. This will make your models way more deterministic. Also, most platforms and inference engines will let you set the seed value that the model uses for its randomly selecting tokens for seeding the diffusion space or something. Pick a set seed for everyone, such as 3,407, which I have found an academic paper that clearly demonstrates that 3,407 is the best seed, and they don't know why, but they have found that it's the best seed. This will make your model way more deterministic, because if you change the random seed, you make the randomness deterministic, eh? Also, one of the other main parameters you have for AI stuff is something called the temperature. The temperature is what controls the randomness of the output. Higher temperatures can cause more amusing results, but higher temperatures can also cause the model to become wildly predictable and go off the rails. Set the temperature as low as possible. To make it easy, I have a table. And this table is for the task and the desired temperature. If you need things to be strictly factual or for data entry or summarization or something where the details matter, The temperature should be 0. There should be no additional randomness. It should be as deterministic as possible. Otherwise, you just have to use a technique that the AI industry, unironically, real life, calls vibe eval, to just figure out what number works best by the vibes of the response. My chatbot Mimi uses a temperature of 1 because, like, let's face it, the worst case scenario for Mimi is that people are going to laugh. Nobody's going to be negatively affected if she just says, like, you know, tacos are made out of, taco shells are made out of cheese. I'm also pointing this out because some inference engines will set the temperature to 1 by default if you don't set 1. And this can and will bite you. I had to find that out the hard way. Another strategy that you can use is something called filter models. Because let's face it, users will try to break your model and make it tell you how to make pipe bombs. You don't want your AI product telling people how to make pipe bombs, because that could get you love letters from the FBI. You don't want love letters from the FBI. Thankfully, Facebook, Google, and other companies have created this paradigm called filter models. A filter model is something that sits in the middle of your AI flow. If a user input passes the filter, it goes to the model. If it fails, the user gets info that it failed, and if you're polite, you'll tell the user why it failed. The output of the model is also passed through the filter to make sure the user didn't manage to smuggle an input that makes the model generate an unsafe reply. This can help you make sure that user inputs are passing muster or standards or something, and making sure that your AI models don't advocate for obviously horrible things under your nose. The two most popular filter models are LlamaGuard from Facebook and Shield Gemma from Google. Shield Gemma? I think it's Shield Gemma. Both of them come in a few different sizes, but something of note, that says LlamaGuard 3 8B. That is 8 billion parameters. Most of the models that you're going to use for production stuff, you should probably start at 70 billion parameters, but LlamaGuard 3 is the thing that I'm recommending, and it's only 8 billion parameters. You might wonder, why is that? That's because a specialized fine-tuned model can always be smaller than a general purpose model. If you're fine-tuning it for a specific task, such as making sure the user isn't asking how to make a pipe bomb, that doesn't require as much general intelligence as, like, you know, how do I make pie, how do I make apple pie, or given all of this data, which company is performing the best? Or, I forgot, Alexa, how do I make pancakes? Fine-tuned ones are fine-tuned specifically for the exact use case you need, and they can always be smaller than general purpose models. Like when I've been running Mimi in my home lab, the part that I left out is the cloud model runs in the cloud, but the filter model runs on a local GPU in one of the machines I can look at. You could also get access to hosted copies of these models. I think Facebook's offering an inference thing, but there's this website called OpenRouter where you can get access to basically any model under the planet, or on top of the planet. Also, filter models have been very bad in the past, but they've gotten way better. One of the funniest ways that LlamaGuard backfired me in testing was that one day that Mimi decided that everything was election interference. Language models have gotten better, which have made this better. I'd love to see what a reasoning filter model would look like in practice. That sounds like a bunch of chaotic fun. In conclusion, AI stuff isn't scary or expensive. The devil is in the details of how you balance the complexity around, but you can cheat. Tools like SkyPilot and philosophies like nomadic compute can help you make sure that the workloads are sustainable. Your model can't be deprecated if you host it yourself. Host what you're most comfortable with. Buy the things that you're less comfortable with. This will mean that you're going to spread your workloads between clouds, but you'll be less beholden to any individual platform. And if they jack the prices up, you can actually just leave. Other platforms will be there with open arms and good deals. Cheat. Take advantage of user behavior. Batch processing is back. You don't need to pay for idle workloads, so spin them down. Users don't need the sparkle emoji button to work if they're asleep. Also, if you can't self-host a model, make sure there's an exit strategy by having the model be self-hostable at all. This means that if a provider goes insolvent or deprecates the one AI model that you're using, you don't have to worry because you can get it elsewhere. If you're familiar with the concept of hexagonal architecture, this is kind of similar if you look at it from a moving plane, but it works out in practice. Before we get things wrapped up, I want to give a moment to give special thanks to everyone on this list for helping make this talk shine. Thank you so much. And thank you for watching. I've been iaso, and I'm going to linger around for questions, but we have time for questions right now. But worth noting, if I don't get to you and you really want an answer, email mimibestbot@zserve.us, and I'll get back to you as soon as I can. Like I said, this is my second conference talk this week. I fly out home to Ottawa tomorrow morning. I may take a while to respond over email because I'm going to pass out and sleep for like 3 days. I have a link here to supplemental material on the Tigris blog, and there's also some things that didn't make the cut for time. Scan it with your phone's QR reader. I promise it's not a Rickroll this time. Either way, have a great conference all. I've got stickers. And we have time for questions.
Yeah, we'll open the floor to questions.
Yeah.
Yeah, so I'm in the self-hosting phase right now. So what if, as the models get better and smaller model could make do, or I'm just using a very specific model, would self-hosting still work? Do I really have to go that way with the cloud?
You can't, okay, so there is something that has been happening. Like when Llama 3 first got released, Facebook released the 405 billion parameter model. It was the biggest open weights model that scored the best. It was like scoring the same level of GPT-4. At the end of last year, Facebook released a 70 billion parameter model, Llama 3.3, that scored just as well as their 405 billion parameter model did. And in general, there seems to be some sort of like scaling wall at GPT-4, and because a GPU VRAM is so limited, every company is trying to find ways to make models run better on lesser hardware, because if you can unlock being able to use consumer GPUs, you know, like you don't have to pay for you don't have to have employees donate their kidneys to get more servers. So we're going to see more local stuff.
Yeah, to that end, I was wondering if you've looked at two techniques. One is quantization. Maybe you've had some hilarious results by doing that, but that seems like a low-hanging fruit to try. And then the other one was decomposing a model so you could run it on like multiple nodes. I'm wondering if anyone's working on that.
Quantization, I forgot to mention quantization in this, but yes, effectively, models are giant bags of floating point numbers. Quantization is the process of doing lossy compression on those to make the bit size of those floating point numbers smaller. Personally, when I do most of my AI workloads, I run my models at 4-bit integer quantization, and like the difference between there is some loss from the like 16-bit floating point to the 4-bit integer, but I don't know what it is, and the vibes are fine, so like it's good. There are methods of distributing models between machines. I tend to like single GPU setups because they're easier to think about and they're easier to spin up and down in groups. I do know that Apple Intelligence, with their server model, they do have a ring of 3 M2 Ultras for doing their big model. Does anyone else have any questions? There's a microphone.
Could you just follow up as well on the horizontally scaling models as well, which was, I think, your question? Like if we're doing that right now, or what that could possibly look like for smaller
Horizontal
CPU?
scaling, the main barrier there is GPU silicon. And otherwise, it's just normal auto scaling. Like, you could probably, if you have the right setup, you could probably do it with a horizontal pod autoscaler in like AWS with Amazon's managed Kubernetes. I mostly do my horizontal autoscaling by having something manually contact the vast.ai API and spinning things up and down on demand. But like, everything's a trade-off. It's just a simple matter of programming, you know? There's another one.
It was a really good talk. You mentioned something in your presentation about hosting the weights on the server and then using an API call to access those weights. I wonder
Yeah.
if you can say more about that. I thought that was pretty interesting.
Let me find that in the slide real quick. Mostly so that I have like a visual aid for this. But okay, so like I said, models are giant bags of floating point numbers. And generally with your inference setups, you're going to have like a bunch of models that you could possibly pick between and the models that are actually being used. So what your model storage thing, like in Tigris object storage or like NFS, if you're feeling old school, is going to basically just be like a big thing with a bunch of hard drives. Like here I have the oxygen icon for like many hard drives piled on top of each other just to symbolize, you know, like storage, big data, bigger than RAM. And the model storage stuff is kind of important because it's a place where if that fails, that can have lots of side effects on the rest of your setup. Like in my home lab, I have the stuff backed by Tigris in the cloud, and then I have it locally cached into Longhorn and also replicated across multiple nodes in the cluster, so that like if my GPU node does die, that the Longhorn will just be like, oh, the GPU node died. I'm going to go rebuild the disk image now. Like the Olama pod won't be schedulable because I hard code it to that exact GPU model, and that's the only machine in the cluster that has it. But like the data will not be lost.
Okay.
But the stuff local to the home lab is mostly a cache.
Okay, gotcha.
There's one in the back.
Hi. So for the temperatures, you had summarization and like for analyzing financial documents.
Yeah.
I was wondering what you thought of for classification. Would that be like closer to summarization, or what your thoughts are on that were?
I would need to know more about the task at hand to give a good answer for what temperature to use for classification, but generally start with as low as possible. Start with 0 and work your way up to find what works best, and for some reason, the seed 3407 is all you need. I don't know why either, but that seems to work.
All right, thank you.
I have the slide at the end with the QR code has a link to like all of the stuff, including that paper called torch.manual seed 3407 is all you need. Any more questions? Oh, perfect. It's at tigrisdata.com/blog/affording AI chatbot friends. Oh, great. I thought I fixed the QR code. I think I loaded the wrong slide deck. I am sorry. I will get a amended version of this as soon as possible. Actually, hold on. Let me find my phone and hit merge on a PR on GitHub, and it'll show up on the blog for Tigris. I would do it on the screen, but I don't feel like leaking GitHub secrets to you today. I'm sorry. We could have had exciting, we could have had NDA violations, but you know, we're not doing it this time. I mean, yeah, you're getting live updates during the talk, yeah. Okay, so merge pull request. Make a thing public. Okay, it will be on the main blog page in about a minute once Vercel builds it. So we have a workaround. You had a question?
Well, I had both a comment and a question. On the CFAR data set, that value 3704, 3407, I'm imagining that the reason that number happens to work better is just because something like 2% of the images are mislabeled in that data set, and it's probably just getting accurate answers, you know, sort of randomly. Good point. I was wondering about that.
I don't entirely know why it works, and like if you read the paper, this guy will say like, I have done some intensive looking into this, and I don't understand why it works, but it makes the number go up, and like you want the number to go up, right?
So, yeah, it's a fluke though. You know, sometimes
Yeah.
you win a jackpot. I had a question. You made a comment, and I was typing at the time. Something about using WireGuard, you could run something in user space.
Yeah.
And I didn't quite follow that. I was wondering if you could
Okay,
go over
so WireGuard is a VPN protocol, and it takes stuff it takes like IP packets, encrypts them, and then fires them out over UDP to a target. There is fundamentally nothing special about this that prevents you from running it in user space. Like there's the WireGuard Go library published by the WireGuard team that can let you do this. It uses a library called NetStack made by the Google gvisor team that has a full TCP IP stack in user space because, like, let's face it, TCP IP is just weird but bitwise math, right? So yeah, it's possible to run it in user space, and in my experience, I found that user space WireGuard allows you to have your services join your network, kind of like Kubernetes, but kind of like halfway between Kubernetes and not Kubernetes. Yeah, like I was working on
It's easier to set up the whole stack of things you're saying.
I was working on a capture the flag thing built on top of user space IPv6 like that. I need to finish it at some point. That could be a fun thing to release on April Fools. Any more questions? No? I think we're good. Thank you. Like I said, email mimibestbot@zserve.us, go to tigrisdata.com/blog, and you'll get the link to the resources. I am so sorry the QR code did not work. I thought I tested it, but who knows? Maybe my laptop synced the wrong version.